right, so let's take a look at section 7.2, part 2. Okay, basically, big part of this section is going to be, we're going to take a formula that has trig in it and change it to a formula without trig. So we'll take something that has like sines, cosines, tangents. We're going to get rid of them, okay, and rewrite it with just algebra. Okay, so some things we'll keep in mind. We're going to use Pythagorean Theorem. Okay, that's going to come in handy. And SOHCAHTOA. Okay, so knowing sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent, what's tangent? Opposite over adjacent. Okay, so those things will come up as well. Okay, let me show you an example kind of as you write that down so you can see what I mean. Okay, so you're going to have a formula. There's going to be an inner trig function, and then there's going to be one on the outside. Okay, the goal, okay, is going to be to start with that inner trig function. We're going to focus on that first. Okay, and we're going to use that to draw our picture. Okay, then once we set up a picture, it's going to make solving this whole thing a lot easier. Okay, and what's nice about the way we're going to do it, I'm going to show you how you can check if your answer is right on the calculator. Okay, so you'll get your answer, we'll plug it in, we'll plug that in and see if they match. Okay, so I already said keep in mind the Pythagorean Theorem. Okay, we're going to use that. And the second part, I'll explain this once we get going. Okay, so in this case, our inner trig function is inverse trig. We're going to rewrite that after we get going. All right, so that inner trig function is inverse trig. Does anybody remember what we use that for? Is inverse trig used to solve for the length of a side or how big an angle is? Has to do with angles, right? Pythagorean theorem, that's what we use for sides. Okay, inverse trig we use to find out how big an angle is. Okay, so for now, I'm going to forget about what's on the outside. Okay, I'm not even going to look at that. I'm just going to write down the inverse cosine of v is going to equal some angle. Okay, we don't know what it is. I'm just going to say that if you could figure it out, it would equal something. Okay, and now I'm going to do this. I'm going to rewrite this using regular trig. Okay, I want to get rid of inverse cosine. Does anyone remember what function cancels out inverse cosine? Cosine. Okay, so I'm just going to take the regular cosine of each side. Okay, and what that's going to leave me with on the left is v by itself. So v equals cosine theta. All right, now I need to set up a picture for that. Okay, I'm going to draw a right triangle diagram. Okay, and somehow I have to make this statement true. Okay, so here's our triangle. You can put theta wherever you want. Okay, it doesn't matter. But I want the cosine of this angle to come out to a certain answer. It has to come out to v. Okay, so what two sides am I going to be using here? Cosine. We're going to use hypotenuse. Yep, that's good.
Adjacent.
And adjacent. All right, so somehow we've got to label the adjacent side, and we have to label the hypotenuse, so that when we do this divided by that, the answer comes out to v. What's the simplest way you can divide two things and have the answer come out to v? Anybody think, what could you put in the top and what could you put in the bottom to make it as simple as possible? What number?
1.
Yep, I like the idea of using a 1. Where would you put that, in the top or the bottom?
Bottom.
Yep, the bottom. And what would you put in the top?
2.
2 divided by 1 is not v.
V.
V, yeah, just put v in the top. Okay, so if you can set up a fraction where the adjacent side is v and the hypotenuse is 1, when you do adjacent over hypotenuse, you'll get v. Now that's not the only way to do it. You could do 2v over 2, and then when you divide, you get v. But just try to pick the simplest fraction you can. Okay, so that usually means using a 1. So we'll make the adjacent v, make the hypotenuse 1, and now the cosine of this angle is v divided by 1, which is v. Any questions on labeling those two sides?
How about the other side?
Yeah, now we got to get that third side. Okay, if we have 2 out of 3 sides, how can we get the third side? Yeah. Now we'll use the Pythagorean Theorem, and then we'll get the third side. Okay? And the reason why we need this third side is because what we really want is the sine of this picture. Okay? Well, we have the hypotenuse of the picture, but we don't have the opposite. Okay? If we use the Pythagorean Theorem, we'll have opposite, we'll have hypotenuse, and then we can answer the question, what's the sine of this? Okay? And we just represented that as a picture. All right. So we'll fill in. We can call it A if you want. We're going to cross that out in a second, as soon as we figure out what the Pythagorean Theorem gives us. But Brendan, can you fill in what I would have with the Pythagorean Theorem using A, V, and 1?
A squared plus b squared equals 1.
Yep. And when you square it, you just get 1. So A squared plus B squared equals 1. Okay, remember, I'm trying to get A by itself. So I'm going to subtract V squared. And my last step, I got to get rid of this exponent. We'll take the square root. So A is the square root of 1 minus V squared. Okay, and when you do this, you're going to see this kind of stuff a lot. Square root of 1 minus something squared. Okay, that's the length of the side opposite. Okay, and that's the hard part. That's pretty much the whole problem. Okay, now we're just going to use that to answer the question, okay, what is the sine of the inverse cosine of v? Well, this whole picture represents inverse cosine of v. Okay, we wrote that whole thing as a picture. Now we're going to take the sine of that picture. Okay, Tyler, what two sides does sine use?
Opposite and hypotenuse.
Yep. So opposite is square root of 1 minus v squared over hypotenuse. In this case, it's just 1. So we could just write square root of 1 minus v squared. Right, so if you wanted to take the sine of the inverse cosine of some number, instead of doing it that way, you could just do this formula. Take 1 minus your number squared, and take the square root of it, and it would come out exactly the same. So we took a formula that had trig in it and rewrote it as a formula without any trig. And what I'm going to do is I'm going to graph what's on the left in y1. I'll graph what's on the right in y2. And they should match up and be the same. Okay, that's how you can see your answer is correct. If the graphs look different, then something's wrong. All right, so let's type in sine of inverse cosine. Remember, you have to use x. You can't use v. And let's type in what we think the formula is, square root 1 minus x squared. 1 minus x squared. Okay, I'm in radians, that's fine. And I'm going to just do zoom 7. I think that'll be a good window. Okay, it was quick, but did everybody see how it traced over itself? It was blue first, and then it traced over it in red. Okay, these are exactly the same thing. Okay, you can also check on your table. You can just pick a few values and type them in and see that they come out the same.
What did you type for y1?
y1, I put the original problem. The sine of the inverse cosine of x. And then y2, I put what we thought our formula was. And since they graphed on top of each other, it doesn't prove it, but it suggests that they are the same thing. The proof is what we did with all the algebra. Okay, we'll try another one of those. Okay, any questions on that? Yeah?
You just move the calculator over so we can just finish copying the model.
Okay, so anytime you have a problem where it's a regular trig function on the outside and an inverse one on the inside, You do exactly the same steps every time. Set the inside one equal to theta. Rewrite it, getting the v by itself. Draw your picture. Use the Pythagorean theorem. And then go back and answer the original question. And again, you're going to see the square root of 1 minus v squared. That comes up a lot. Okay, square roots. All right, so Cameron, what would be my first step here? I'm going to take that inside trig function, and what do we set it equal to?
You set it equal to.
Yep, and you, in the last problem, how did we represent our angle?
Theta.
Yeah, you can use anything you want, but usually for angles we use the Greek letter theta. Okay, now my next step, I'd like to get v by itself. And so John, how am I going to get rid of inverse sine and just have v?
You're going to multiply by sine.
Careful. I like the idea of using sine, but multiply we can only do with numbers.
Oh.
No, he's right with sine. It's kind of like if you said this. Would you say multiply each side by the square root?
No.
What word would you use instead of multiply?
I don't know. I'm going to take this two.
Take, yeah. Usually you say take the square root of both sides.
Actually, yeah.
So we're going to take the sine of both sides. Okay, definitely understand we are not multiplying. Okay, we can't multiply by a word. All right, so that cancels out. And we get v equals sine theta. Okay, now Kyle, how do I want to represent this? Instead of writing it as an equation, what do I want to do now?
Put it in your triangle.
Yep, we want to make a picture of it.
It doesn't matter where we put theta, right?
Nope, it doesn't. If you put theta at the top, it's just going to change where things line up, but you're going to get the same answer.
Yeah.
Okay, now I want the sine to come out to v. So Matt, what two sides do I use for sine? Opposite over hypotenuse. And what's the simplest way to label these? So I take the sine, and I get an answer of v. Sure. Opposite over hypotenuse. Now, if you did that out, this diagram matches what this equation says. Sine is equal to v. And now my last step for the diagram is to do the Pythagorean theorem. I'm going to end up getting the same thing I got last time. Square root of 1 minus v squared. Does anyone want me to go through that again? No. It's going to be the same thing. All right. Now we can answer the original question, which says find the tangent of the inverse sine. All right, so Upi, what two sides do we use for tangent? So opposite over adjacent. So we get v divided by square root of 1 minus v squared. And last time we could stop at that step, but what's wrong with it this time? Yeah, we've got the square root in the bottom, so we fix it like we always do. Multiply top and bottom by the square root. So we get v square root 1 minus v squared over 1 minus v squared. If I wanted to check and make sure my answer was right, I would probably plug the original one in with the square root in the bottom. I think that's easier to type into a calculator than this one. You can type this in, it's just you're going to need a few more parentheses, and it's a little harder to type in. Any questions on that one? All right, a couple things a little different about this one. Same idea, you've got two trig functions. But anybody tell me what's different about this one compared to example? Okay, this time we have an actual number. Okay, which sometimes that's easier. Okay, we're not going to have to deal with a letter in this problem. Okay, and what else is different? Yeah, this time the inverse is on the outside. The regular trig function is on the inside. Okay, we're still going to take the same approach. We're going to start with the inside trig function. And just see what we can do. All right, so first thing they want us to figure out is the tangent of 3 pi over 4. Okay, so we're gonna see if we can figure that out first. In case we're not sure what that is, what's 3 pi over 4 in degrees? How much? Pi is 180.
270.
Well, what's pi over 4? No, pi is 180. Because if you know pi over 4, then you just have to triple that.
360.
No, 360 is 2 pi.
240. 135.
135.
Somewhere.
Pi over 4, that's a 45. And then we're tripling it, so this is 135. You don't have to change to degrees, but if it's easier for you to visualize that in your head, maybe you want to do that. All right, so let's just start with this. Okay, we're finding the tangent of 135. Worry about the inverse sign later. Okay, this is going to have to do with a special right triangle. Do you think it's going to have to do with the 30, 60, 90 or 45, 45, 90?
45, 45.
Yeah, the angle here is a multiple of 45. Okay, so let's see if we can make a sketch, figure out where we are. Okay, 135 is in quadrant 2. Okay, so here's a 135-degree angle in red. Okay, roughly about like that. Okay, so we're finding the tangent of that angle. Okay, to do that, what we do is make our reference triangle. Okay, we're going to make a triangle right there where the hypotenuse is the terminal side of that angle in red. Okay, just to make it bigger, I'm going to draw this triangle over here. Bigger so we can see it. All right, and we said that this is a 45, 45, 90 right triangle. So it's 45, that's 45, and 90. Now, if we want to find the tangent of 135, we just have to label these sides. Okay. What kind of triangle is this?
Right.
It's a right triangle. What else?
Equilateral.
It's not equilateral, but we're on the right idea. It's isosceles. Okay, two sides are equal. Now, if you want to find the trig function of an angle, it doesn't matter how big or small of a 45, 45, 90 you can use. You can use ones where the sides are 10 feet long or 10 inches long. That doesn't matter, as long as you label it correctly. So we've got two sides the same. So I just picked easy numbers. If you don't want to use 1 and 1, you could use 7 and 7. You could use 12 and 12. It just has to be two numbers that are the same. And the hypotenuse would be using the Pythagorean Theorem, square root of 2. Okay, any other 45, 45, 90 triangle is going to be similar to this. You can make it bigger, you can make it smaller. It's not going to change your answer for tangent 135. Right, so I just picked easy numbers to work with for the sides that I knew were the same, then use the Pythagorean Theorem. All right, now we want the tangent. Okay. This is our reference angle, right there. Okay, it's always the angle between the hypotenuse and the x-axis, whether you're in quadrant 1, 2, 3, or 4. It's always the angle that's close to the origin. Okay, so now I want the tangent of that angle. All right, so tangent is opposite over adjacent. In this case, we might have to restart the program. All right, so I think we're we're back. So I think I was saying in this case, they're asking for tangent. Okay, so you're probably not gonna need the hypotenuse, but if they were asking for sine or cosine, you would be using it. Okay, so in this case, we're not gonna need it. Okay, there's my reference angle, right there. So what's the tangent of 135? Okay. What quadrant are we in? We're in quadrant 2. So the y value in quadrant 2, is that positive or negative? Y is positive. What about x? If you want, you can label it like that, although the side is not really -1 units long. But remember, you went left for x. So tangent of 135 wouldn't be 1, it would be -1. Okay, it's opposite divided by adjacent. And remember, you went left. That's what makes it negative. If you were in quadrant 1, then it'd be positive. All right, so any questions on how we got tangent of 3 pi over 4? All right, so now that simplifies our problem quite a bit. So now we can say they just want the inverse sine of -1. Right, and there's a couple ways you can think about it, but I think the easiest way is to think of your graph of sine. Okay, it looks like this. What's the highest that sine hits? And the lowest? -1. And when they're asking for the inverse sine of -1, all they're really asking is, what angle on this graph do you have to go to hit -1? Okay. Does anybody remember what that angle is right there? No, not 3 pi. How about in degrees? Do you remember it in degrees? 90. 90 is right there. 270. Okay? Remember, that's 0, 90, 180, 270, 360. 360 is one full period. So we're at 270 degrees, which is the answer to this problem. If they wanted degrees, what about radians?
2 pi over 3.
Other way, 3 pi over 2. Okay, so in radians, that's 3 pi over 2. Right, so for a problem like this, if I was going to have you use a graph, I would have to have it come out to 1, 0, or -1. Okay, if it came out to something other than that, you wouldn't be able to look at the graph in your head and figure it out. Okay? Okay. Now, what else is that equivalent to? You could write 3 pi over 2. Anybody know another answer you could see? Keep in mind what the period of sine.
6 pi over 4.
What's the period of sine? How often before it repeats itself? Every 2 pi, or every 360 degrees. So we said the answer here is 270. Now, that answer is going to reoccur again right here. It's going to occur again. It's going to keep reoccurring every 360 degrees. It's also going to reoccur the other way. What angle would that be?
90 degrees.
That's -90. Okay? That's also an answer. Which answer they want, it depends on what they say on the test. They could say, write your answer between 0 and 360, in which case that's correct. If they said, write your answer between -90 and 90, okay, you would want to write -90. Okay, the directions on the test will tell you which one they're going to look for. They're not going to ask you for an answer that's way out here. Okay, they're going to ask you for one that's pretty close to the origin, either the first positive answer or probably the first negative answer. Okay. Any question on how we found that? You just have to know that this answer repeats every 360 degrees, backwards and forwards. Okay, so don't get frustrated if you're looking and it's a multiple choice and you're like, wait, I think I did everything right and I don't see this answer listed. Well, see if they wanted this one instead. Okay, you might have done everything right.
I just don't know how you're getting the answer. I don't know what to do.
To get this negative pi over 2?
Just to get any of it, I'm not following at all.
Like how we got the 3 pi over 2?
I mean, like, I don't know, like, I don't follow it.
So this part, to get from this part to this part, we kind of relied on memorizing the graph of sine. All right, so we have to know that sine looks like this. There's other ways to do it besides the graph. Okay, but if you know this is what the graph looks like, when they're asking about inverse sine, that means where does the graph hit -1? Okay, if you don't know the graph of sine, we'd have to do it a different way. Okay, we could do it a different way. Is anybody that didn't remember this graph? They're like, I thought it was like a straight line or something. The sine function. Okay. Cosine function looks very similar if we ever have to deal with that one, except it starts at the top and comes down. Okay. How many people remember that one for cosine? That was okay. So like if I said to you, let's say I asked this question. Inverse cosine of, let's say, 0. Okay, what I'd be asking for is on the graph, where does it hit 0? What's that angle right there? 90. Yep. That's 0, 90, 180, 270, 360. Okay, so yeah, it hits it at 90, and then it also hits it again at 270. Okay, which answer would they want? Again, it just depends on the directions. Okay. If I said, where does inverse cosine hit -1? What angle is that at? Yeah, 180. Okay. Again, do they want positive 180 or negative 180? The directions will tell you. All right. So we'll practice some more of those, but you're not going to have too many where you have to visualize the graph like this. You're going to have more where the inverse is on the inside and the regular is on the outside. All right, so this one is back like the one we started with. Okay, first and second example of class. Except this time you don't have a letter. Okay, everything is all numbers, so when you do Pythagorean Theorem, we're going to have all numbers as our answer. All right, so thinking back to those first two we did, not the last one. That one was a little different. What's the first thing we do when we have the inverse function on the inside? Yep. Yep, we're just going to write it down by itself. And then we're going to take the sine of both sides. Okay, any question on those first step? And right now, we've got this as an equation. Our next step, we want to visualize it by doing what? Yep.
You're going to be doing a triangle, right?
Yep, we're going to make a triangle. And this time, we don't want the sine of the angle to equal a letter. We want it to actually equal 1/2. All right, so Paige, what two sides am I using for sine?
Opposite and hypotenuse.
Opposite over hypotenuse. And that's exactly what you should label your sides as. Opposite, hypotenuse. And then Pat, how do we get that third side?
By doing the hypotenuse over the adjacent comma. Whatever the inverse of that is.
Think back, this isn't trig, this goes back to geometry.
Oh, back to geometry, then.
Yep, no trig for this part.
Oh, can you do the.
It's a right triangle and you know
Yeah.
two sides. How do you get that third side?
So we're not using trig.
Nope, you're not going to use sine, cosine, or tangent.
Pythagorean Theorem. I was
Yeah.
going to say that, like do the a squared, b squared, and c squared.
So we have
Remember that.
hypotenuse squared,
4.
1 squared. For now, you can call the bottom side A, but we're going to have that answer in a second. So bring your 1 to the other side. And Tyler, how long is that bottom side?
Square root of 3.
Yeah, we'll just write it as the square root of 3. Okay, the only problem with a square root is if it ends up in the bottom, we have to fix it. Okay, sometimes that happens, sometimes it doesn't. Okay, and my last step is to find the cosine of that picture. Okay, so what's the, Dalton, what's the cosine of theta there?
Square root of 2.
Yep, perfect. Square root ended up in the top. There's nothing else we need to do. We're done. Okay, so it's exactly like the first two problems, except instead of using a letter, we use a number. Okay, I think this type is a little easier than that last one. Okay, so any questions on that? Yep.
Where did you get the square root of 3 over 2 from?
So adjacent
Yeah.
over hypotenuse, because they wanted cosine.
Oh. I got it.
Okay, if, let's say they wanted tangent, what would happen there is you'd have opposite over adjacent, and then you'd have to fix that.
Times both sides by the...
Yep, so if you had opposite over adjacent, you'd have something like this, and that's how you'd fix it. So it'd be square root of 3 over 3. Again, that's for tangent, that's separate, so. All right. All right, and last thing we're going to do is look at using the calculator a little bit to solve some trig equations. Okay, remember that if a trig equation has one solution, it has infinitely many. The reason, if I said to you, where does sine hit 1? Well, it hits it here, here, here. It keeps hitting 1 forever. Okay? In fact, it'll hit any number between -1 and 1 forever, going left and right. So if you have one solution, you automatically have many. And then how often do they reoccur? Yeah, it's every period. Okay. So for sine and cosine, the period is usually 2 pi. Remember, if we did something like this, okay, that changes the period. That's your horizontal stretch. Okay. So the period in this case is 2 pi divided by 3. Okay. We had this formula, just write it down. T equals 2 pi over b. That's how you find the period for sine and cosine. Sine, cosine, and also secant and cosecant, they're reciprocals. And we use this formula for tangent and cotangent. Okay, so those are your formulas for finding the period, where b is the number in front of x. Sine 3x, cosine 2x, things like that. Okay, if you do want to graph this, remember you don't have buttons for secant, cosecant, or cotangent, so you'd have to type like, I don't know, type in cosecant as 1 over sine. Or if you want to type in cotangent, it's 1 over tangent. Okay, I think we've talked about that. All right, so. All right, so find all real solutions to sine of x equals 0.6. All right, so 2 ways we can do it. One, we can do it algebraically. The second way is graphically. We'll try one of each. We'll do one algebraically, and then we'll check our answer graphically. And I think the second one we'll just do graphically. All right, so let's just think of our graph of sine and figure out how many answers are in one period. Okay, that's step one. Find all the answers just in one period first. Okay, and point 6 might be right there. So what I did is I basically imagined graphing sine of x and y1, 0.6 and y2. Okay. How many times do those graphs cross? 2. Okay, they cross twice. All right, so let's get our first answer. Okay, how would you get x by itself there? How would you get rid of sine? Yeah, use inverse sine. Okay, if I take the inverse sine of what's on the left, take the inverse sine of what's on the right, you get your first answer. X equals the inverse sine of 0.6. Right, let's just see what we get. Yeah. Second, inverse sine, 0.6, we get 0.644. That's that first answer right there. All right, now we need to get the second answer.
The inverse sine of 0.6?
Yep. Did you get something different?
Yeah,
Are you in radians?
I might be there.
Looks like everything's typed in right.
Yeah.
All right, let's see. Have we looked at this diagram before? A couple people say yes. You think so? All right, maybe we just need a reminder. All right, this diagram shows you where your trig functions are positive. Remember that?
Oh.
So in quadrant 1, all of them are positive. If you take the sine, the cosine, or the tangent of any angle in quadrant 1, it always comes out positive. Quadrant 2, the only thing that's going to come out positive is the sine. So if you pick angles between 90 and 180, and you take the sine of them, I guarantee they come out positive. In quadrant 3, the only thing that comes out positive is your tangent. Okay, pick any number between 180 and 270. Guarantee if you take the tangent of it, it's always positive. And lastly, quadrant 4, your cosine is the only thing that comes out positive. Everything else is negative. All right, so what that's going to do is help us narrow down where the second answer would have to be. Okay. 0.6. Okay. What kind of number is that? Positive or negative? Positive. Okay, so we know there's 2 places where we're going to get an answer. One answer is in quadrant 1. The other answer, quadrant 2. All right? That answer is quadrant 1. Okay, how do I know that? Instead of thinking as 0, 90, 180, 270, think of it in radians. This is 0. This is 1.57. Okay, 90 degrees is 1.57 radians. 0.6 is between 0 and 1.57. That's how I know it's in quadrant 1. My next answer is going to be in quadrant 2, which is between 1.57 and pi, 3.14. Okay, so I'll put the decimal just in case you need that. Okay, so now you have the degrees and the radians for both. And 0 radians and 0 degrees, it's the same thing. All right, so now we just have to figure out, if we have this answer, how we would get that answer in quadrant 2. Okay? Remember, this angle right here, think of it as an angle in a triangle if you want. Okay? It's right there. Okay, it's 0.6 radians. What I'm trying to do is to find this answer in quadrant 2. It's almost like a mirror image. of this triangle. Okay, but I'm in quadrant 2. Okay, so here's your first angle, right there. Here's your second angle, right there. What I just drew in red, that's the second answer. Okay? Basically, if you wanted to think about it visually, you would mirror image that triangle into quadrant 2, and you would find the distance in degrees from here to there. Well, if this is a mirror image, what do you know about this angle and this angle? Yeah, they're the same thing. These triangles are congruent. Okay, they're mirror image. Okay. How far is it if you went all the way around? Or I'm sorry, halfway around?
180.
That's 180. Okay. Now, if you wanted to stop a little bit before 180, what would you do with this angle right here and the 180? You'd subtract it. So let's say this, I'm just going to use an easy number. Let's say this angle was 10. If that's 10, then this would be 170. If that angle was 5, it would be 175. Now, I have an answer in radians. So I'm going to use 3.14 instead of 180. And what am I going to do with 3.14 and 0.644?
Subtract them.
Just subtract them. Okay. And that's your second answer. All right, so we got 3.14 minus 0.644, 2.496. And that should be that second answer. Okay, what I'll do is I'll graph it and I'll check, okay, and see. If they don't specify how you get your answer, you can graph it or you can do the algebra. If they want you to show the algebra, though, then if you just write the answer, you wouldn't get the credit. Okay, so just make sure you just do what the directions are asking. All right, so let's graph sine of x. Let's graph 0.6. Okay, and remember, I'm finding the two answers that are in these quadrants. Okay, so you can ignore everything else on the screen. Let's just find these two. Second calc, intersect. Okay, so it says the first answer is 0.644. Okay, that's the one that we got just by doing inverse sine. And now the second answer, to figure it out, we did two things. We used our diagram to figure out where sine is positive. And then we figure out if you're in the second quadrant, you always subtract from 180 minus your angle. Okay, that's the rule for quadrant 2. So let's see if we get that second one. 2.498. We had 2.496. It's just because of rounding, but we did it correct. Any questions on that? Okay, now those two answers we have, is that every single answer? No, what should we add onto the end of it? Because this answer is going to keep repeating forever. How often?
Every period.
Every period? And what's the period of sine? 2 pi. Okay. I think we've talked about that before, the plus 2 pi k. That represents it's going to keep repeating forever. Okay, and the second answer also keeps repeating forever. All right, so you just find both answers in one period, either algebraically or this next one we're just going to do graphically. And put plus 2 pi k. All right, so this one, how do we type that in? Because we don't have a button for cotangent.
1 divided by tangent.
Yeah. Okay, so I'm going to type in 1 divided by tangent. Okay, and what am I going to put in y2? 2.5. And I'm going to try to see where these graphs cross. Okay, if you do zoom 7, you're going to see multiple periods on the screen. Okay, what I want to do is just focus on one of them. Generally, I focus on the first positive period. It's not wrong if you want to use a different one. It's the same thing. Okay, but I'm going to focus on this one right here. All right, so how can I find where these two things cross? What do I have to press? Second calc, intersect. Do your guess. And it says they cross at point 0.381. Now, how often does that answer repeat? Think about the period of tangent. How often? No, and it's going to repeat even more than every 2 pi. Yeah?
Every pi?
Every pi. Right? So your next answer, okay, to get to that next answer, it's going to be plus pi and plus pi. Okay, the period for tangent is just pi. The period for sine and cosine, that's 2 pi. Okay, and the way you could check if you're not sure, take what your answer is, add pi to it. That should be where they cross the next time. See if that's true. 3.521. So let's go here. 3.522. Okay, just because of the rounding, it's a little off. Okay, and the next answer would be that number plus pi again, plus pi. Just keep adding pi, and you're going to keep getting all those intersections. Okay, so the only mistake you could really make here is if you do plus 2 pi. That would be wrong. Okay, any questions on that one? All right, so any questions on anything we went over today? I know this diagram might have been a little tricky. Does anyone have any questions on that? Once you get used to it, it's not too bad. Okay. So we realized in quadrant 2, it's 180 minus that angle. How about if you were in quadrant 3?
Then you would have 180 plus the angle, right?
Yeah. If you wanted to end up all the way right to that hypotenuse, you'd go 180 plus that angle. And you're going to have that angle from the first part of the problem when you do it. How about, let me just get rid of that. These aren't exactly congruent, but pretend. What about if you wanted to be in quadrant 4? Yeah, this time you're almost going all the way around, except you're short this much.
Subtract it from here.
Yeah, so this one, maybe I'll write these down. 360 minus the angle. This one is 180 plus the angle. Quadrant 2 is 180 minus the angle. And quadrant 1, that's the answer the calculator gives you. Okay. So using that combined with this tells you where your trig functions are positive. Okay. This tells you how, once you have your reference angle, how to get the angle in the quadrant that you want. Okay, this tells you the quadrant you want. What if I asked you, where is tangent positive? Just make sure we can read this.
Quadrant 3.
Quadrant 3 and?
Quadrant
1. Yep. How about, where's cosine positive?
1.
4 and 1. Where's sine positive? second quadrant and first quadrant. Yep. Okay. Where is tangent negative?
Quadrant 1 and quadrant 4.
Nope, everything's positive in quadrant 1.
I mean quadrant 2 and 4.
2 and 4, tangent is negative. How about where's sine negative? Which quadrants?
3 and 4.
Sine is negative in 3 and 4. Yep. So depending on what the question asks, you can figure out what quadrants you want to be in. And then once you answer the question I just asked you, then just follow the formula. Quadrant 4, okay, 360 minus my angle. Quadrant 2, okay, 180 minus my angle. So you kind of use both of these together. Yeah, but we can practice those more. All right, so I think that's it's a good stopping point. I'll give you a little time to start the homework or ask me questions if you need to. Okay, it's on 394, 37, 38, 41, 42, 45 to 47, and 49 to 53.